Welcome to section 5.2. In 5.2, we're going to look at a very specific discrete probability distribution called the binomial probability distribution. So there's some things that we want to be able to do. One is to define it. The second is to understand it. Understand maybe when you have it. When you have a binomial distribution. It actually happens a lot. And then when you have a binomial distribution, the third thing that we want to teach is using the binomial probability formula. It's going to unlock a lot more problems for us. And not problems in terms of things that are difficult, but problems in terms of probability questions that we haven't been able to ask yet. And so we'll present all of that here for you. So let's go ahead and define it. The binomial probability distribution must meet all of the following criteria. Number one, fixed number of trials. Okay, you can't just do something forever. It won't work in terms of the binomial probability formula being able to help you. You have to have something done a set amount of times. This one's never violated. Nobody ever says, hey, roll a die an infinite number of times and tell me the probability that you get a 6. We already know that. It's 1/6. So we don't do things on an infinite level. Number two, for each trial, there are only 2 outcomes. That's where it gets its name. It gets its name from the fact that there's 2 outcomes. So bi means 2, right? Like a bicycle has 2 wheels. For each trial, there are only 2 outcomes. 3. Trials are independent from each other. That's an important thing. And number 4 and 3 are closely tied. You have to have a very obscure type of setting in order for them not to be tied in. The probability of success on an individual trial remains constant from trial to trial. So there's the definition. You can bring that with you when you come to take the exam because we allow notes and stuff. And so our job is to understand it, right? So here's step 1, to define it. Number 2 is to understand it. So we're going to work a little bit on that. So there may be problems in the homework and on the exam that ask you, is this situation binomial or not? Historically, I put those on the exams. And then when there's not that direct question, we want to be able to understand, yes, this is an appropriate application of the binomial probability formula because this setting is binomial. So let's take a look at some settings, and we'll come back to each one of these categories. So, and I'll just roll the screen back and forward here. So let me put a big line so I know where that definition is when I come back up. So let's suppose we do this. We flip a coin 10 times, keeping track of the number of heads obtained. Is this binomial? Is this a binomial situation? Lots of things are. Okay. Flipping a coin 10 times, keeping track of the number of heads obtained. So we need to go and check out each one of these. So the purpose of the example is not just to say yes or no, it's to have you understand what each of these numbers mean, right? And what I mean by numbers, each of these criteria that need to be met. So let's focus on criteria number 1. Fixed number of trials. That means that a trial is how many times we're doing something. Maybe we're selecting people. In this case, we're flipping a coin. Maybe we're drawing marbles out of a hat. Those types of things. As you look at this example, is there a fixed number of trials? And the answer is yes. The coin is only being flipped 10 times. So the number of trials is 10. The number of trials has a letter associated with it, n. So n is 10. The number of trials is 10. Okay. Second one. So we've met the first criteria. For each trial, there are only 2 outcomes. So what we mean by a trial is one of those flips. It could be the first one, but it should be for each one. So how about when we flip the coin the very first time? What are the 2 possible outcomes? Or are there more than 2? Each time we flip it, because of what we're focused on, we have a heads, or technically not a heads, but we know that that's a tail, right? So every time we flip that coin, it's either heads or it's not a head. And so there are 2 outcomes. So I'll highlight that one in blue. So for this guy right here, we have to think about what could come out with each trial, head or tail. Now think about that one trial. This represents the first flip of the coin, also the 5th flip of the coin, also the 9th flip of the coin. Every time I flip it, whether it's the 1st, 2nd, 3rd, 4th, 5th, all the way up to the 10th, it's either heads or tails. Now, if I got a head on the first one, does that make me more or less likely to get a head on the next one? And the answer is no. What is that probability of success? So let me highlight this last one here. 3 and 4 are closely tied. But let's answer this one. What is the probability of success on an individual trial? When you flip the coin the first time, what's the probability that you get a head on the first flip? And it's 1 out of 2. Okay. Oh, it isn't always 1 out of 2 in a binomial situation. We'll show you other examples, but it's 1 out of 2. On the 3rd flip, it's also 1 out of 2. On the 10th flip, it's also 1 out of 2. On the 7th flip, it's also 1 out of 2. No matter what trial you're on, the probability of success is the same. Now the probability of success has notation. Little p is 1/2. We'll also want to know the probability of failure. So p is the probability of success. And that's staying constant from trial to trial. They're independent of one another. So this one is yes. Remember the original question is this binomial? Yes, it is binomial. Awesome. Okay, so now what we're going to do is we're going to go look at another situation. Let's suppose we roll a die 7 times, keeping track of the numbers rolled. Well, if we go through, remember what the yellow one was, fixed number of trials. Do we have a fixed number of trials? And the answer is yes. I have 7 trials. So I am going to continue to take the time to tell you that the number of trials, number n, is represented by the letter n. So n is equal to 7. Now why am I stressing that? Because you're going to go put these numbers into a binomial probability formula. And I want you to understand what those variables stand for. Now, let's ask the second question. The second question is the blue question. The blue question is, for each trial there are only 2 outcomes. Well, as you flip a coin, what are the possible outcomes? 1, 2, 3, 4, 5, 6. we have a problem. For that blue outcome, we have more than 6. This is not binomial. More than 2 outcomes. On a trial. Okay? Not a binomial situation. Hopefully that makes sense to you. There's 6 things that could come out. I needed only 2. So I don't want you to leave this thinking, oh, well, rolling a dice is not binomial. It's all a matter of what you're focused on. How about this? Roll a die 7 times, keeping track of the amount of 3s rolled. If you go in with a focus, then we should be good. So I'm not going to flip up to the top. I hope that's okay. I'm just going to talk through it. Remember, the first one was fixed number of trials. Yes, we have a fixed number of trials. The number of trials is equal to 7. That's never violated. They're never going to say, let's roll a die a few times. If they don't specify the amount, then we can't do anything. And how about on each roll? On each roll, what could we get? Well, we could get a 3 or not a 3. There are only 2 outcomes. I know that there's a 2, a 1, a 4, a 5, a 6 that could come out, but we're classifying all those as not what we wanted. When you have a focus, it's binomial. And so, well, it has at least 2 outcomes. I can't say that it's absolutely binomial because it could not be independent. So let's talk about that. When you roll a die and the first time and a 3 comes up, when you roll it a second time, is it more or less likely to come up with a 3? No, it's the same likelihood. What is the probability that we roll a 3 on one roll? So I'll put on the first roll, because that's what a trial is. It's one of them. The probability that we roll a 3 is 1/6. We know that. It's one option out of 6 things that could equally come up. So 1/6. That would be the same on the second and on the 5th, right? And on the 10th, well, there's not a 10th row, a 7th row, right? All of them would be 1/6. So the probability is remaining constant from trial to trial, right? That's the red one. So let me put that highlighter in there and come back and write over it. The probability of success is 1/6 on each row. Little p will represent the probability of success. This is binomial. Okay, so you can see it being violated if there's more than one outcome, but you could fix your focus and have it work out this way. What about something like this? In a bag, there are, and we'll get creative here because we can, 4 blue marbles. 6 red marbles. And 5 green marbles. If actually, let me use a number that's not up here. If 9 marbles let me not word it like that, because that's going to get into the probability question, and those come a little bit later. So this is the first part. We select 9 marbles, keeping track of the colors chosen. Okay. Fixed number of trials, absolutely 9. N is 9. on one pick of a marble, what are the options that are present? Blue, right? Red, and green. That's a problem. That's 3, which is not 2. So this is not binomial. Okay. So again, we ran into the same issue that we did with the dice. If we weren't paying attention to a particular color, it could not be binomial. So it's not binomial because more than 2 outcomes. If you're okay, because this is something where I can erase, let's go ahead and change this. So you could back up the video and see that example, but let's change this a little bit. Let me get rid of some of the markings in here. We select 9 marbles, keeping track of the number of red marbles chosen. Awesome. Have we fixed the problem? Seems like it, right? That's what worked for the thing. 9 marbles. N is equal to 9. We have a fixed number of trials. As we go to select a marble, right? As we go in and select a marble, what are the outcomes? The outcomes are red or not red. Well, that's only 2. What is the probability that when you first reach into the bag, red on first? Okay, we do have to check this. Is it independent? Does the fact that I chose a blue marble on the first one or a red marble on the first one affect my ability to get a red marble on the next? Let's look. What's the probability that you get a red on the first? Well, you can see that there's 6 red marbles out of, it looks like, 15 marbles. Our book's going to want us to reduce that, so I'll model that. So you got a 3/5 probability. What then is the probability that you get a red on the second pick? We need it to be the same, but it's not. If you got a red on the first and then you go in to reach in again, something happened. What happened was we have lost a marble, and we're down to 5 reds. So now when I go in to reach, there's only 5 reds out of 14, and these are not the same fraction. Remember, this is a dependent setting right here, and so we need these trials to be independent. This is where in the previous chapter, right, in chapter 4, you would drop down 1. Well, that's a problem. Your probability is not staying constant from trial to trial. So this is not binomial because the probabilities aren't the same. Or you could write because the trials are not independent. That's a true statement as well, that third quality, or that third criteria. Third and the fourth are very interrelated. How did we see it? We saw that the probability in the second pick was directly affected by what happened in the first. Back here, it wouldn't have made a difference at all if the first one roll was a 3. When you pick up that die and roll it again, all 6 numbers are present, and one of them is a 3, so it stays 1/6 every single time. So you want to evaluate the situations critically, right? Make sure you're thinking the right way, and justify each one of those. But this is the first 2 steps to understand the binomial distribution. What we need to recognize is that if something's binomial, we can find out some probabilities that we could never figure out before. So we'll save that for a part 2, and I'll create that video and then post it right after this one.